Hey everybody, this is Mr. Piercy here, and what we're going to be taking a look at is how we actually use the midpoint and distance formulas in geometry. Ideally, if you're doing this in class with me, you have worked through the midpoint and distance investigations that let you see where the formulas came from in the first place. If not, then you can kind of still follow along with this and get a good understanding of what they do. The names are fairly self-explanatory. The midpoint formula shows you where the middle of a line segment is, and the distance formula shows you how long a line segment is. So we have a couple of vocabulary terms. Midpoint, obviously, that's fairly self-explanatory. A segment bisector can really be a point, array, a line, anything that kind of intersects a segment at its midpoint. So it doesn't have to be just a line segment or anything. A segment bisector is literally anything that cuts another segment in half. So moving on, understanding what we have here, what we can recognize looking at this diagram here, let's pick a color that's not just black. Here we can say that segment VW, well, not is a bisector, but bisects. Let's change it a little bit. Segment VW bisects segment RS. Now they don't have to tell me that segment VW is bisecting segment RS. The hash marks that we see here indicate that segment RT is congruent to segment TS. That's what those hash marks are indicating, and that's also what allows me to conclude that VW has to be a segment bisector, or that point T is the midpoint, however you want to think of it. So looking at it here, that again, we can say that point T is the midpoint of the segment. So RT and TS have to be equal in length since they're congruent to each other. And using segment addition, we can recognize that the entire segment RS is equal to the two smaller parts. Substituting the values that we know for those segments gives us a overall segment length of 43.4 units from point R to point S. So moving on, same idea. They're letting us know straight away that point C is going to be a midpoint of segment BD. And we know that a couple of ways. First of all, it tells us right here, but it also lets me know using the hash marks that BC is going to be congruent to CD. So that means their lengths have to be the same thing. So that's what allows me to write our equation right here that BC has to equal CD. Substituting the expressions that we have in this case, we have a 3x minus 2 to be equal to 2x plus 3. And this is going to become a very common thing that you'll see in geometry. We're kind of doing this lesson at the beginning of the year, and this is one of the first examples that we're seeing where we're kind of introducing an algebraic expression to represent the length of something rather than a number like we saw in the previous example. So that's kind of one of the reasons why that geometry is always going to come after Algebra 1, because there is a fair amount of geometry that's applied, or a fair amount of algebra that's applied into segments and angles and figures in geometry. So now that we have our equation set up, we're going to just use our opposite operations. Moving the smaller figure, smaller variable to the larger one, I'm going to move the 2x from the right side to the left side through subtraction. And that will give me a new equation of x minus 2 is equal to 3. Move the 2 over through addition, and it gives me x is equal to 5. So now that I know that x is equal to 5, I can substitute it back into the expression that I want to solve for. We want to find the length of BC. Well, since BC is equal to the expression 3x minus 2, I'm going to substitute the 5 in for the x and show that BC is actually going to be 13 units long. So at this point, what I'd like you to do is go ahead and pause the video and answer this checkpoint question on your own. It tells you that point K is a midpoint. Find the length of segment KL. And go ahead and pause the video, work this problem out. When you have your answer, come back and see how your work looks for against mine. Okay, so the first thing that I'm going to do, looking at this, since it's asking me to find the length of KL, I have to know what the value of x is first. Well, based on the fact that they're telling me that k is the midpoint, that allows me to conclude that segment JK has to equal segment KL. Substituting their respective expressions into the equation that we have, JK is equal to KL, solving for x gives us 3/5. Now that I know that x is equal to 3/5, I can substitute the 3/5 into the expression for KL and then solve for x, which would give us 6 1/5 or 31/5 as an improper fraction. So that's how long segment KL is going to be. Now here is the formula for midpoint, meaning that if we know the endpoints of two coordinates, we can use this formula right here, which is the average of the x's and the average of the y's, and identify where the actual midpoint formula is. I'm sorry, not the midpoint formula, but where the midpoint of a segment is going to lie. So looking at this, it's asking us to find, well, we have two examples here. So in part A, it's asking us to find a midpoint, and in part B, it's going to give us the midpoint and ask us to find the other midpoint, or other endpoint. So let's go ahead and take a look at example 1. Using the midpoint formula, and this is what I would encourage everybody to do here, is anytime you use a formula, I really suggest that you write the formula down every single time you use it. So I'm going to say x1 plus x2 over 2 and y1 plus y2 over 2. That's how we're going to find the midpoint formula. Now I can start substituting my numbers. Now whether you call point P point 1 or you call point R point 1, it really doesn't make a difference. We're still going to add the two numbers together, and we're still going to take half of that sum. So looking here, substituting the x and the y coordinates into the midpoint formula gives me -2 plus 4 for the x's and 5 plus 3 for the y's. Simplifying the expression, adding the numerators, and then dividing by 2 gives me an expression, final coordinates of midpoint to be at 1 and 4. And you can kind of see in the graph that they're giving you, that's exactly where that coordinate is. I know it's kind of, you know, why do I have to do the formula if they're showing me where the midpoint is? Well, it's just to make sure that, you know, it just confirms that you're getting the correct answer that the formula is, you know, by using the formula. Now, most students are not going to have a very difficult time using the midpoint formula if I give you both both endpoints and ask you to find where is the midpoint. However, if I change it up just a little bit and say, well, here's one endpoint and here's a midpoint, tell me where the other endpoint is. A lot of students will struggle with that for some reason. It's the same concept, same formula that we're working with, and that's what we see here. We're looking to find what is the coordinates for C. Now again, you can kind of count on the graph to see where the coordinates are, but that's not the point. We want to see what is the formula give us. So again, my recommendation, anytime you use a formula, write it down. So x1 plus y1, or x2 over 2, and y1 plus y2 over 2. What we're going to be doing here is we're not going to work it all together at the same time like we saw in the example part A. If you notice, we have a step 1 and we have a step 2 because we're going to have to do the same process to figure out the x-coordinate of the endpoint and the y-coordinate of the endpoint. Well, substituting the values that we know, we have an x-coordinate for a midpoint and an x-coordinate for an endpoint. So we're going to substitute those numbers into the formula where they belong. So for step A on the left side, we're going to take the x-coordinate of point A and the x-coordinate of the midpoint that was given to us and substitute them into their respective spots. Same thing with the y-coordinates. I'm going to take the y-coordinate from point A and the y-coordinate from the midpoint and substitute them into their respective spots in the formula. So let me just as an aside, let me just kind of look at this bit right here. That is like saying x1 plus x2 over 2 is equal to m. And I often will say m sub x to let you know that I'm using the x coordinate of the midpoint. And here on the right side, that's the same thing as saying y1 plus y2 over 2 is equal to the y coordinate of the midpoint. So that's kind of where I'm getting those numbers from. What I think causes students to have a hard time is the fact that we now have a denominator of 2 that I have to take care of first before I can uh, figure out what the solution of my problem is. In the last example, we were able to just add the numbers in the numerator and then divide by 2. Well, in this case, since the variable that we're looking for is in the numerator, we can't just add the numbers and then divide by 2. We have to get rid of the 2 out of the denominator by multiplying both sides by 2. Let me go ahead and pick another color here so not all the red blends together. What we're doing is I'm going to say on the left side of the equal sign I'm going to multiply by 2, and on the right side of the equal sign I'm going to multiply by 2. We're going to do the same thing for the y's, and when I do, I'll be left with 1 plus x is equal to 6, because here 2 divided by 2 is equal to 1, and on the right side 3 times 2 is equal to 6. So that's how we're winding up with 1 plus x is equal to 6. We're going to do the same thing here. We'll multiply this by 2, multiply this by 2. Here, 2 divided by 2 simplifies to be 1, but 4 times 2 gives me my 8. Now it's just a very simple matter of moving the x and the y coordinates over and showing that the x coordinate of point C will be 5 and the y coordinate of point C would be 2. So the way that we express our answers is C would be at 5, 2. So that was the midpoint formula. Moving on, we're talking about the distance formula. Distance meaning that now we're going to be able to use this to find, well, how long something is, regardless of whether it's a horizontal or a vertical line. Most of the segments that we're going to be looking at, finding the length of in geometry, won't be horizontal or vertical. I want you to pay attention that the order that I take the difference of the x's or the difference of the y's really doesn't matter. Most geometry textbooks and online resources will give you what we're seeing in that top row, but I want you to understand, because I'm taking the difference, it doesn't matter what order I put them in, because when I square it, I'm always going to wind up with a positive number after I square something. So that's why the order that we subtract the x's and y's don't matter, as long as we're consistent throughout the problem. If I say x2 minus x1, I have to say y2 minus y1 in order to get the, keep the equation, working properly. So let's take a look at the example here. We definitely cannot count diagonally in this case, so we're kind of stuck. And I've taken the liberty of labeling point T and point R to let you know which one I'm calling X1, which one I'm calling Y1, and so on. So that way we can see how we're substituting into the problem. We want to know what is the distance. Now, the one thing that I want to change here that I'm going to address as we go through the problem, you see here it says the approximate length. Well, whenever possible in high school geometry, let alone any kind of advanced classes that we have, we really want to avoid approximate numbers whenever possible. And instead, we want to try to determine what are the exact values of something. And I'll explain what we mean by that when we get there in the problem. So we start off again by writing the formula, x2 minus x1 squared plus y2 minus y1 squared. Now, substituting the numbers that we have for x1 and y1, y2 and y1, we're going to get here negative 4 minus 3 squared in one set of parentheses and 3 minus 2 squared in another set of parentheses. Now, please make a note of how we're writing the square root symbol each and every time until we get to our final answer. And we're not getting rid of the parentheses at any time until after I square something. So using my order of operations, combining my like terms inside of the parentheses gives me negative 7 squared and a positive 1 squared. Now again, don't worry about the fact that negative 7 is inside of the radical symbol here, but make sure, especially if you're working on a calculator, make sure you keep that negative number in parentheses on your calculator, because if you tell your calculator negative 7 squared, the calculator is going to give you a negative number, and that would be bad. Because what you're telling the calculator at that time, you're saying take negative 1 and multiply it by 7 times 7, or 7 squared. And that's what's giving us a negative number. Whereas if you tell the calculator, say, negative 7 squared like that in parentheses, you're telling the calculator take negative 7 and multiply it by negative 7. And that's how we're going to get a positive number. So whenever you square a negative number in your calculator, always make sure it's in parentheses. So that'll give me 49 plus 1, and when we combine those numbers underneath the radical, we get the square root of 50. Now this is where we need to remember how to simplify radical numbers from our previous math classes. When we simplify numbers, usually what I explain it as is I want to know, well, are there any factors of my radicand that are perfect squares? In this case, 50 has a perfect square factor that is the number 25. So I can rewrite the square root of 50 as the square root of 25 multiplied by the square root of 2. Well, the square root of 25 just becomes 5, so my final solution would be 5 radical 2. And 5 radical 2 is what we would refer to as the exact answer. Because if I say the square root of 50 on my calculator and get a decimal number, I get 7.071, but that's not where it stops. We have to round it at some point. So instead of rounding a number, whenever possible, we would like the exact answer. So in this case, the exact answer is 5 radical 2, whereas the approximate answer would be about 7.01 or 7.07. Please keep in mind that in pre-AP and AP math, we do round to 3 decimal places automatically unless we have some specific instructions not to. So here the length of segment RT would be 5 radical 2 as an exact number, or 7.071 as an approximate answer. So at this point, what I'd like you to do is go ahead and pause the video and tell me what is the approximate and the exact length of segment GH. Again, it doesn't matter which one you call point 1 or point 2. They'll work out to be the same either way. Go ahead and pause the video, work out this problem, and when you're done, hit play, and let's compare your work versus mine. Alright, so hopefully you have a good answer. Again, anytime you start with some problems, you should write the formula down. And my square root symbol, unfortunately, doesn't go across the whole way. Pardon me. Sorry, I'm having a little bit of allergy issues today. So let's go ahead and keep everything the same color. So all of this should kind of be like that. So as we go through substituting our numbers, x1 and x2, it really doesn't make a difference which one you label them as. For the difference of the x's, you're either going to get a positive 8 or a negative 8. For the difference of the y's, you're either going to get a positive 7 or a negative 7. Just remember, on your calculator, square the negative number by putting it in parentheses. So we get the square root of 64 plus the square root of 49. Adding those numbers together, we get the square root of 113. Now, the square root of the number 113 does not have any perfect square numbers that are factors. So the square root of 113 is where I would stop as the exact answer. But if I want the approximate answer for some reason, I would say 10.630 as an approximate number. So that's going to take care of this set of notes here where we're talking about the midpoint and the distance formulas. Midpoint formula is something that we use to find where the middle of a line segment is, or to find where the endpoint is if I know where the midpoint is. Midpoint also indicates that we're dividing something evenly into equal parts, so we can say one part is equal to the other part. And the distance formula is something that we use to find the length of a line segment when It is not going to be a horizontal or a vertical line. Keep in mind, we prefer exact answers in high school versus approximate answers, but we'll take what we can get sometimes. Try to keep your answers exact whenever possible, though, and if you have to give me a decimal number, make sure you round it to 3 decimal places. So that's going to take care of this video. If you have any questions about anything you've seen, by all means, let me know what your questions are. I'll be happy to help you out. But until next time, guys, thanks for watching and take care.